morning. Today we are starting with the word problems, and for that first we'll generate some results. And these results already I have discussed in June class, but I'll simply revise them and then we'll do questions on it. So if anyone have not connected that time, that will get the benefit of it, right? So here in this case we are having this is the universal set, this is set A, this is set B, and let the number of elements in set A is given by Na, number of elements in set B is given by Nb, and the universal has number of elements n mu. So Na, Nb and n mu. And my question is you should find out what is Na union B. And this is the case we have in which the sets are joint set. So when the sets are joint, we have A and B, and I want A union B. So when you want A union B, that means you need this complete result or complete reason. So I should write this as NA, number of elements in set A. Then we want number of element in set B. This is complete set A, this is complete set B. Now the problem is this L part you have taken twice. You have counted this in A, you have counted in this in B. So that means when you take NA union B, it should be counted only once. So as it is counted two times, I should subtract it. So minus NA intersection B. This portion was A intersection B, so I have taken this. So first formula is NA plus NB minus NA intersection B. Second thing, or one more result, if I say you want NA minus B. NA minus B means only this portion will be taken. This is your NA minus B if I take. So it is NA minus B, that is this portion. If you want A minus B, that means what I'll do here, first I'll take the number of elements in set A. And from this, I subtract this part, so I get this portion. So minus NA intersection B. Same way if I say it is B minus A, then I should say it will be NB minus A. That will be NB minus NA intersection B. So these are the results we should have for two joint sets. NA union B is NA plus NB minus NA intersection B. And A minus B will be NA minus NA intersection B, and B minus A will be NA minus NA intersection B. If they say number of elements which belong to only one set, if they ask only one set means either I want this portion or I want this portion. That means we'll say only A, N, that is only A. And then number of elements only B. When we say only A means it will be NA minus B. And when only B means NB minus A. And now when you solve it, it will be NA minus B. If I say it will be NA minus NA intersection B. This will be NB minus NA intersection B. Or you should say your result come out to be NA plus NB minus twice of NA intersection B. This is the number of elements which belong to only one set. If they ask, you can get this result. So one formula is this, second formula is this, third formula is this, fourth formula is this. Okay, in this case, and one more thing now note here, the universal set, that is this total, that always come out to be greater or equal to the union of the two. This is formula also you should remember. This is the fifth result we should know, that universal set is always greater than or equal to NA union B. So these are the results we are going to have when we have a joint set. By the way, if it is disjoint set, if they are disjoint set, then the change will come here will be, this is set A, this is set B. And when I say NA union B, it will be NA plus NB because this part is going to be 0. So first formula now this time when joint sets are disjoint set are there, NA union will be NA plus NB. Then we have NA minus B. This is your A minus B itself. So in that case, again this part will be removed. Left is NA. Same way if they say B minus A, so this is B minus A this time, and this will be left only NB. Then number of elements which belongs to only one set. In this case, it will come out to be NA plus NB because this portion is going to remove, this portion is going to remove. This is simply come out to be NA plus NB is the result we have. So if they are disjoint set, we should know the result is going to change, or we'll say all the intersection portion are going to be removed. So this way we have certain result for two sets. When we have three sets, when we have three sets, what will be the formula? We are also going to do that. So if you have three sets, joint I am taking A, this is B, and this is C. These are the three sets A, B, C. And I want what is NA union B union C. NA is the number of elements in B, A, then B, then come out to be C. So if they are asking A union B union C, when you do this, first will be A complete, that is NA. Then B complete, that is NB. Then C complete, NC. Okay, this is NA, then NB, then NC. Then in this case, just check here, this portion. First, if I just consider this portion you have taken in A also, you have taken in B also. So that means this is taken twice. One time you should subtract. So minus NA intersection B. Same way when you go for B and C, this is you have taken twice, should be subtracted here, B intersection C. Same way this portion if I take, it is again to be subtracted because you have taken it twice. So NA intersection C. But now you take this portion, that is the intersection of complete. This portion you have taken how many times? Just check. You have taken this in complete A, you have taken this in complete B, this is you have taken complete C. 3 times you have added. 1 time, 2 times, 3 times. How many times you have subtracted? Just check here. In A intersection B it is here, subtracted. B intersection C it was subtracted. C intersection A it was subtracted. So 3 times subtracted, 3 times added means you have not taken that result at all. So that means you should count that also. So NA intersection B intersection C. This is the formula we have for NA union B union C is NA plus NB plus NC minus NA intersection B minus NB intersection C minus NA intersection C plus NA intersection B intersection C. So this way you will be having the formula for A union B union C. By the way, if they are disjoint sets, then these intersection will be removed. Then if it is disjoint, then NA union B union C come out to be simply NA plus NB plus NC. Nothing change. All the intersection will be removed. So we will say simply the addition of ABC we are going to have. So one formula is this when joint set, and this is when disjoint set. So that you should keep in mind. Now coming on some more results here. If I say you find out elements, number of elements which belong to exactly two sets. If it belongs to exact two sets, means it belongs to A and B, or it belongs to B and C, or it belongs to C and A. That means we want these portions here. Either this part or this part or this part we want, because these are the parts which will be shared by 2. So when you want this portion, how you calculate, just check here. This will be A intersection C. This was complete A intersection C, but this we don't want, so we subtract it. N A intersection B intersection C. Plus, second time I'll take this. This is N A intersection B, complete. From this again we don't want this portion, so N A intersection B intersection C. Same way when we think about this, it will be B intersection C. And from this portion again to be removed, so minus N A intersection B intersection C. So when you solve it, what this will come out to be? N A intersection B plus N B intersection C plus N C intersection A minus 3 times N A intersection B intersection C. This is the formula we have for exactly two sets if the element belong. Same way they can